Hello all, welcome. My name is Kastro Kiran. Welcome to this new video series on shell scripting for DevOps engineers. In this series, I am going to cover everything that you need to know about shell scripting from the basics to the advanced automation techniques that are essential for the DevOps workflows. Whether you are a beginner or looking to refine your skills, this course will help you to write efficient and powerful scripts in order to automate your daily tasks as a DevOps engineer. At the end of each lecture, assignments will be provided to reinforce your learning through the hands-on practice. To make things even easier, there is a dedicated GitHub repository where you can access all the lecture notes and also the assignment questions as well. The link to the GitHub repository is available in the description of this video. Without further delay, let us see what are the topics that we are going to cover as a part of lecture 1. So firstly, what we are going to learn is we are going to see the Linux architecture, and once after we understood the Linux architecture, then we are going to understand the fundamental concepts of shell scripting and also shell scripting as well. Once we complete this one, then we are going to write a shell file, and then we will see how to execute a shell file by using the different approaches. So these are the topics that we are going to cover as a part of this video. Before we move to the concept of shell scripting, let us understand the concept of Linux architecture. Let's say there is a machine that is available. For every machine, we know there are some hardware components such as motherboards, chip, graphic card, and couple of other things that will be available for any machine. So here, when I say machine, it is typically a laptop or the desktop. Now, as an user, you want to communicate with the machine. You want to communicate with the machine. Now, the question is, can we directly communicate to the hardware components of a device? Technically, you cannot directly communicate to the hardware components of a device. Why? Because we don't have the direct access to the hardware components of a device. The question is how we can communicate with the hardware components of the device so that we will see the desired output in the machine. For that, let us understand the fundamental backend process of the Linux architecture. Let's say if you want to provide the instructions to the hardware components of any device, we will have a component which is called as kernel. So by using kernel, we are going to provide the instructions to the hardware components of a device. Again, here also, can we directly provide the instructions to the kernel? It is not possible. So if you want to provide instructions to the kernel, you need to interact with shell. So this is the process how you can communicate with the hardware components of the device in order to get the desired output. So first the user will be there. User will be interacting with the shell. Shell will convert the language into kernel understandable language. Kernel will convert that language into hardware understandable language, and hardware will give us the desired output, whatever we were trying to execute. So this is how the backend process of Linux will work. Now here, the most important component is how to work with shell. So that is the main aim of this lecture series, where we are going to understand how to work with shell and how to write the shell files by using the different approaches. Let us understand what is a shell. Let's say you have launched one EC2 instance in the AWS cloud. Now, if you want to connect to that EC2 instance, we are going to use a third-party tools such as Putty, Puttygen, and MobaXterm. Let's say in my case, I am going to use MobaXterm to connect to the server or to connect to the EC2 instance. Now, once after you connect to the EC2 instance, you are going to see a terminal, something like this. And this is where we have been executing the different Linux commands in order to interact with the server. Now, what is a shell here? Shell is something which is going to provide an environment where we can run the different Linux commands. So that's typically the definition of a shell. Shell is also responsible to process or read the instructions that is given by the user. Let's say you want to know what is your present working directory. So we have a Linux command which is called as a pwd. So that is something which is a command given by the user. So what a shell will do, shell will read that information and shell will process that information, and then shell will give us the desired output if the command is correct or if the syntax of the command is correct. So this is what a shell is. Now let us understand how shell will work, the shell working process. So as an user, first what we will do is whenever we want to execute any command in the terminal, shell will read the command and will check the syntax. And if the syntax is correct and if the command is also correct, then shell will convert that command into kernel understandable format or kernel understandable language. Once it converts into kernel understandable language, then it is going to communicate with the hardware components of the device. So then kernel will read the instructions which is given by the shell, and then kernel will convert that instructions into the hardware understandable format. Once it converts the commands into the hardware understandable format, then we are going to see the output of the command that we were executing. So this is the entire process that actually runs in the backend whenever we execute any command in the terminal, especially the mobile system or any other terminals that you are working with. As a part of this lecture series, I'll be using AWS Cloud to work with shell files, and I'll also be using the mobile system as a terminal to connect with the Linux instance and to execute the different shell files that we are going to see as a part of this lecture series. So as of now, what we have understood is we have understood the Linux architecture, and then we have seen how shell will process the instructions that is given by the user. So shell processing also we have understood. Now let us understand what is meant by scripting. What is meant by scripting? So typically the definition of scripting is scripting refers to writing. Scripting refers to writing a series of commands in a file. Okay, scripting refers to writing a series of commands in a file that can be executed in order to automate the tasks. In order to automate the task. So this is the simple definition of the scripting. Okay, this is the simple definition of scripting. So here, why we need to automate the task? That is most important. Suppose let's say you have multiple commands that you want to execute on a daily basis. Now, when you want to execute multiple commands on a daily basis, every day, let's say at 9 o'clock in the morning or at 10 o'clock in the morning, you have to execute some basic commands. Now, instead of executing all the commands one by one, what I will do is I'll keep all these commands in a file. I'll keep all these commands in a file, and I will just execute this particular file so that whatever commands that I have kept inside the file, they will get executed. So scripting refers to writing a series of commands in a file that can be executed in order to automate the task of DevOps engineers. So here what we are doing is instead of manually typing, okay, instead of manually typing all the commands, okay, instead of manually typing all the commands, what we will do is we can store them, okay, we can store all the commands in a file, and that file is called as a scripting file. That file is called as a scripting file, and then we shall execute, okay, then we shall execute the file to perform. We shall execute the file to perform the tasks in an automated way. To perform the tasks in an automated way or automatically. So that is the main concept of scripting. That is the main concept of scripting. Now the question is, why scripting is required? Why scripting is required? So for time being, we have understood that shell scripting is used to something to perform the task in an automated way. To perform the task in an automated way. Why we need to perform? Because I don't want to type the commands manually on daily basis. So what I am doing, I am going to keep all those commands in a file, and that file is called as a scripting file. And once I keep the commands in the scripting file, I am going to execute that file so that all the commands will get executed in an automated way. So why scripting is required? The first concept is to understand the automation process. So why scripting is required? Scripting is majorly required in four different ways. One is to automate the tasks. One is to automate the task. Let's say you have some repeated tasks that you want to do on daily basis. So when you use a scripting, so automate the repetitive tasks that you want to do on a daily basis. Automate the repetitive tasks that you want to do it on daily basis. What are something like repetitive tasks? Let's say I want to take the backups. Every day morning, I want to take the backup of all the files and I want to log the data or I want to analyze the log details. I want to analyze the log details. That is also something which you will do it on daily basis when you are working as a DevOps engineer. Let's say I want to perform the health checks of the my server of my server. So these are something which we can automate by using the scripting concepts. By using scripting concept. And the second advantage of why we need to go with the scripting is its efficiency. It's a efficiency. So what does it mean by efficiency? Let's say I don't want to execute the commands every day. So when you want to execute the commands every day, what will happen? Let's say it is going to take some 10 minutes or 15 minutes of time. So here, if I keep all the commands in a single file and if I execute the file directly, we can actually save some time in order to automate the process. And in the process, we can also reduce human errors as well. In the process, we can also reduce human errors as well. Let's say you want to execute 10 commands on daily basis. Now, on a given day, you might forget to execute some commands. Let's say you might execute only 7 commands. So this is something which is a human error. So to avoid human error, we can also use scripting for that. We can also use scripting for that. And the third advantage is consistency. And the third advantage is consistency. So consistency means scripting will ensure tasks and are performed. Scripting will ensure the tasks are performed the same way every time. Okay, the same way every time. Let's say I have 10 commands. I have written all the commands one by one. So same way, whatever the process that you have written or whatever the command by command you have written, if you are executing the shell file, the commands will get executed in the same way every time whenever you execute the shell file. This is a third advantage of why we move to scripting. And the last one is to monitoring of the applications and maintenance of the servers. Monitoring and maintenance of the servers. Now, question is how we can monitor or how we can maintain the servers. Let's say this scripting will help us. Okay, this scripting will help us in monitoring systems. In monitoring systems. What does it mean by monitoring systems? Let's say I want to take the backups. I want to take the backups. I want to maintenance. I want to do some task maintenance. I want to do some task maintenance. All these things we are going to see as a part of this particular lecture series. So these are the main reasons why we prefer scripting here. Why we prefer scripting. Now to understand the real world scenarios with respect to the DevOps engineers, let us see a couple of scenarios here with respect to shell scripting. So the first one is the automation of backup. So backup automation is the first task. So what does it mean by backup automation? Let's say I want to take the backups of the system on daily basis. Every day, 11 o'clock in the morning, automatically the system has to take the backup. When you go with the scripting, we can automate the backup of the critical data that you want to have on a daily basis. That's the first use case. And the second use case is the analysis of the log files. The analysis of the log files. So scripting will analyze the log files in order to identify the errors or in order to identify the trends that are available in the log files. That is also another real world scenario that we can work with the scripting. And the next one is system health checks. So if you want to perform the health checks of the servers, to monitor CPU, to monitor the memory, to check the disk space, All these things we can do the automation by using system health checks. And finally, we can also do the deployment automation as well by using scripting. Let's say if you want to automate the application deployment process, we can do that by using the deployment automation process as well. Let's say you want to delete the temporary files, you want to clean up the cache data, all those things we can automate by using the scripting concept. By using the scripting concept. So this is about scripting. This is about scripting. Now let us understand what is meant by shell scripting. Let us understand what is meant by shell scripting. So shell scripting, as we understood, scripting means writing the commands in a file and executing that file on a daily basis. That is called scripting. Now the question is, what is shell scripting? What is shell scripting? Shell scripting is the process. Shell scripting is the process of writing scripts using a shell. Using a shell. So technically, we have different types of shells that are available. But the most commonly used shell is bash shell. The most commonly used shell is bash shell. We'll talk about this bash shell in some time. So shell scripting is the process of writing the scripts using a shell in order to automate the tasks. In order to automate the tasks in Linux or Unix environments. In Linux or Unix environments. So this is what the shell scripting will do. This is what a shell scripting will do. So usually any shell script files, okay, shell script files will have an extension, will have a dedicated extension. Shell script files will have an extension as .sh. .sh. Let's say you want to create a Word document, .doc. You want to create a PDF document. The extension will be .pdf. You want to create a file, JPG file, .jpg. Similarly, for shell script files also, the extensions will be .sh, will be the extensions of shell file. Now, let's say you want to take an example of a shell file. You want to take the example of shell file. Let's say I want to create a file with a name called Kastro. I want to create a shell file called with a name called Kastro. So I'll go with Kastro.sh. Kastro.sh. So that is something how we can do that. Suppose let's say I want to take the backup of the data. So I'll create a file with a name called backup, but it's a shell file. So I'll give the extension as a .sh. If you want to check the health checks of the system, so I'll give it as health checks .sh. So I'll keep the related commands inside these files so that when I execute directly the shell file, all the commands that I have written in these files will get executed in an automated way. We'll see this in a practical way in some time. Now, let's say I want to execute some commands on daily basis. I want to execute some commands manually on daily basis. What are such commands? Let's say in Linux, we have some commands. Let's say we have a command called who am I? We have a command called pwd, that is present working directory. I want to see the date. I want to see the date. I want to see the calendar. I want to see the calendar of a specific year. Let's say cal 2025. Cal 2025. I want to see the list of files that are available. I want to see the list of files that are available. So these are some commands which you will execute on a daily basis. On a daily basis. Now let's say to execute these commands, let's say it will take at least 1 minute. At least 1 minute. Now what I'll do, I'll keep all these commands in a single file. I'll keep all these commands in a single file. That file I will execute it directly. Okay, that file I'll execute it directly. So you can keep or you can save all the files, all the commands. You can save all the commands in a single file, and execute that file so that the commands will automatically get executed. So that is the concept of shell scripting. That is a concept of shell scripting. Now, before we practically write the shell script file, let us understand some default syntaxes of a shell script file. So here we have a concept called Shebang. So what is a Shebang in shell script file? What is a Shebang in shell script file? So Shebang is the first line. first line that we will write in a shell file. In a shell file, is it mandatory to write? Is it mandatory to write a shebang in the shell file? It is not mandatory, but it is recommended. It is recommended. So shebang is the first line that we will write in a shell script file. In a shell script file, and we will specify the interpreter and specifies the interpreter and specifies the interpreter to be used to execute the script. Interpreter means bash shell, C shell. Like this, we have different types of shells. We will see them in some time. So here, Shebang is written as hashtag with factorial symbol. Hashtag with a factorial symbol. That is called as Shebang. So Shebang is used to specify which shell should interpret the script. Shebang is used to specify which shell to interpret the script. So the default syntax of Shebang is hashtag factorial symbol space /bin /bash /bin/bash. This is basically for bash shell. So here, what it is going to tell is, it is going to tell the system, okay, it is going to tell the system to use bash shell for the execution. Now, as I said earlier, it is not mandatory to write this one. But it is recommended. For clarity and consistency. So it is not mandatory. To write shebang. But it is recommended. For clarity and consistency. So this is about shebang. So any shell file will start with shebang. What is /bin and /bash? It is something that is going to tell the system to use bash shell for the execution. Bash is one type of shell. So let us see what are the different shells that are available. Different types of shells. So here we have different types of shells. One such shell is bash shell, and the full form of bash is born again shell. That's the full form of bash. And the next one is sh. Which is called as born shell. And the next one is zsh. It is called as z shell. And the next one is ksh, which is called as corn shell. And the other one is csh, which is called as C shell. So these are some of the default shells that are available. Some of the different types of shells that are available. Now, what is the default shell for Linux-based instances? For Amazon Linux, Bash is the default shell. That is available. What does it mean by bash shell? Bash shell will have /bin/bash. So usually Amazon Linux is something which is based on CentOS. Amazon Linux is something which is based on CentOS or Red Hat, RHEL, Red Hat. So these are the different types of shells that are available. Okay, these are the different types of shells that are available. Now, what we will do is, let us launch an EC2 instance. And once after we launch an EC2 instance, connect to the instance. So here, in order to connect to the instance, I am going to use MobaXterm as a third-party tool. And once we write that, then, once we launch the instance and once we connect to the instance, let us practically work with writing simple shell files. Simple shell files, right? So now let me go to the AWS console, and here I am working in a region which is called as Mumbai region. So you can work in any region. You can work in any region. So let me click on launch instances, and here I am going to launch Amazon Linux instance. I'm going to launch Amazon Linux instance. Let's say I'll give the shell file name as, I'll give the instance name as shell scripting by Kastro. I'll give some name to the server. I'll give some name to the server. You can give any name to the server. Even if you don't give name also, that is not a problem. And here I'm going to select Amazon Linux. You can also select Red Hat. You can also select Ubuntu. But we are not working with Mac and Windows. We are not working with Mac and Windows. You can go with Amazon Linux. You can go with Ubuntu. You can go with Red Hat also. Red Hat also. So let us go with Amazon Linux for this video. So I'm just going to use this particular thing, which is called as Amazon Linux 2023 AMI. Amazon Linux 2023 AMI. And then I'm going to select the instance type, which is t2.micro. So this is actually a free tier eligible one. So let us go with the same one. If you have a existing key pair, you can click on this drop down and you can select the existing key pair. If you don't have the key pair, you can create a new key pair. So just click on create key pair. So I'll just give the file name as scripting, shell scripting, and I'm going to select the type as RSA, and I'm going to use the PEM file to connect to the server. So let me click on create key pair so that the key pair will get downloaded. Network settings, I'm going with the default network settings. Storage 8 GB is more than fine. So let me click on launch instance. Launch instance. Now, once after you launch the instance, let us connect to that instance. Let us connect to the instance. Now, in order to connect to the instance, we are going to use the public IP address of the server. The public IP address of the server. So let me select the instance, and here I'm going to copy the public IP address and then go to the MobiXterm. So this is how the MobiXterm terminal will look like. So click on session. Okay, click on session. Click on SSH. Click on SSH, and here paste the public IP address of the server and specify username. For Linux instances, the default username is EC2-user. For Ubuntu instances, the default username is Ubuntu. So let me select advanced SSH settings, use private key, click on the file icon, and select the PEM file that you have used. Select the PEM file that you have used. I have selected the file. Click on OK. Now we have connected to the server. Let me clear the screen. Right. So now let us write our shell file. Let us write the first shell file. So I'll keep it as script one. So here, this script one is something which is related to welcome message. I want to welcome you all with a shell script file. So what is the default first line in any shell script file? So hashtag factorial symbol space /bin/bash. That's the shebang. Now I want to execute, or I want to print an output. I want to print something. So when you want to print something, we will use echo. Let's say I'll give it as enter your name. I'll give this one. So what it will do, it is going to print that. Now, once it prints, it is going to ask the user to enter the name. Now, whatever the user is entering the information, it has to read. Shell file has to read. So read user_name. So whatever the name that is given by the user, it is going to read that name. And then I want to print the message. So whenever you want to print something, echo is the command. Let's say I'll go hello, and then I want to print the username. So whenever you want to print something, we will use a $. So $user_name. So whatever the username that it is going to read, it is going to print that name. Hello space $user_name. And then I want to print something like welcome to shell scripting course by Kastro. So I'm just printing this one. So what will happen here? So first, user will enter the name, and then script file will read that name, and then it is going to print this message. and then it is going to print this message. So let me write a shell file here. So I'll just copy this entire one, go to the mobile system. Now to write a files, we have a Linux command which is called as vi. Let's say I'll give the file name as a welcome.sh. So press enter. Now we are there inside the shell file. So let me go to the insert mode. Press I to go to the insert mode. I went into the insert mode. Paste the shell file, whatever we have written. So now what it will do? First, it will show to the user to enter username, and then user will enter the name. Once user enters the name, it is going to read that name. And then it is going to print this message. Whatever user has entered the name, that username will be given here automatically, and then it is going to print this entire message. Right? We have written the shell file. Press escape :WQ. Come out of the file. If you want to see the commands that you have written inside the shell file, cat space file name, so that you can see the commands whatever you have written. Now I want to execute the shell file. Now to execute the shell file, we have different ways. We have 3 different ways. So execution of a shell file. First one, method 1. Let me write it as a method 1. Method 1 is about giving the executable permissions. Giving the executable permissions to the shell file. And once we give the executable permissions, then we are going to run the shell file. So giving the executable permissions to the shell file before running. So how will we give the executable permissions to a shell file? We have a Linux command which is called as chmod. And when I want to give the executable permissions, I'll go with the +X. X represents executable permissions. And then give the file name. Extension is very much important. .sh. This is how you can give the file permissions. Once you give the file permissions, then you can execute that file. How will you execute a shell file? // file name .sh. This is method 1 of executing a shell file. We have another method which is method 2. In method 2, what we are going to do is we are not going to give any permissions. So direct execution we are going to do. The command is // or sh, not // space file name. sh space file name .sh. This is a method 2. And method 3 is also direct execution. So in method 3, what we are going to do is bash space file name.sh. You can use any of the methods according to your requirement. Let me show you the first method now. So now, first, currently, as I said, for the shell file that we have written, does it have the executable permissions? No. If you see that ls, you can see currently the file is not having executable permissions. If you do ls-l, you can see there is no executable permissions. Only read-write permission is there. Executable permission is not there. So how will we give the executable permissions? Sudo chmod +X. Why sudo? Sudo means root user permissions. Sudo chmod +X file name, that is welcome.sh. Now click enter. Now the file has got executable permissions. If you do ls, you can see the file is in green color, which means the file has got executable permissions. Earlier the file is in white color and now it is turned into green color, which means it has got executable permissions. If you want to cross check again, ls-l, can you see the executable permissions are available or not? The executable permissions are available or not? X represents executable. Now let us execute the shell file. Method 1 /file name. Now what it will ask? First it will ask us to enter the name. So let me click enter. Now you see it is asking me to enter the name. Let's say I'll give my name as Kastro Kiran. Now press enter. Once you press enter, what should be the output that you are going to get? Hello Kastro Kiran V. Welcome to Shell Scripting Course by Kastro. Here we have written, right? This output, it is going to print. Let us see that. You can see that here. Hello, Kastro Kiran V. Welcome to Shell Scripting Codes by Kastro. Can you execute the same shell file multiple times? Yes, you can. We can execute. How will we execute? How will we execute? Dot slash file name, dot slash file name. Right. Now let me enter the name. Let me enter the name Raj. I'll enter. Raj, I'll enter. Press enter. Now you see. Hello, Raj. Welcome to Shell Scripting Codes by Kastro. So like this, you can execute the same shell file multiple times. How many times you have written the shell file? How many times you have written the shell file? Only one time. Only one time. So this is a one-time activity. Writing the shell file is one-time activity. Can you execute the shell file multiple times? Yes, we can execute. So am I writing all these commands every time when I'm executing the file? No, it's not required. So here, am I automating the tasks or not? Am I automating the tasks or not? Yes. So let me execute one last time. Welcome.sh. Let's say I'll give it as Dhoni. I'll give it as Dhoni. Some name I'm giving. Now you see, well, hello Dhoni. Welcome to Shell Scripting Codes by Kastro. Like this, we can execute the shell files and we can write the shell files. Like this, we can write the shell files and we can execute the shell files. Now, let us write one more shell file. Let me clear the screen. Let us write one more shell file that's called as script2. I'll write it as script2. Script2. First script is about welcome message. Second script is with Linux commands. Let us write some Linux commands. Let us write some Linux commands. So any shell file will start with Shebang. Any shell file will start with Shebang. So hashtag factorial symbol /bin/bash /bin/bash. Now we have some Linux commands. Let's say I want to know what type of user I am. I want to know what type of user I am. Who am I? Who am I? I want to see what is my present working directory. What is my present working directory? So pwd is the command. I want to see the date. I want to see the date. So date. I want to see the calendar. I want to see the calendar of a specific year. I'll give it as cal 2025. Okay, I want to see the calendar. Now I want to create a directory. I want to create a directory mkdir, 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 and I'll give the directory name. I'll give the directory name. Let's say I want to create a directory called shell. I want to create a directory called shell, or I want to create a directory called Kastro. I want to create a directory called Kastro. And once we execute that one, I want to create a file. I want to create a file. So touch is the command to create a file. I want to create a file called kastro.txt. Kastro.txt. Now what I'll do, I'm keeping all these commands in a shell file, and directly I will execute this shell file so that all these commands will get executed one by one. All these commands will get executed one by one. Let's say before executing this one, I'll give one message echo. These are executing. I'll keep it as executing simple Linux commands. Simple Linux commands. I'll keep something like this. First, it is going to print this message, and then it is going to execute all these commands. Right. So let me copy this entire thing into the shell file. So currently, how many shell files we have? We have only one shell file. We don't have any other things. Do we have the directories? No. Do we have the files? No, nothing is available. So let me create a shell file vi linux.sh. So I am creating Linux command set. So I'll give some name as linux.sh. Press enter. Go to the insert mode. Now let me paste everything. First, it is going to print this message, and then it is going to execute all these commands. Right. Let me press escape :wq. If you want to verify the contents inside the file, cat space file name. Currently, if I do ls, can I see a directory called Kastro directory here? No. Can I see a file called kastro.txt here? No. Currently, there is no directory called Kastro, and there is no file called kastro.txt. Now I will execute the shell file. As we know, by default, the shell files will not have the executable permissions. How can we execute a shell file? First, we have to give the permissions sudo chmod plus x file name. Sudo chmod plus x file name. So that this particular file will get the executable permissions. Let's say I don't want to work with this file permissions. This is method 1. We have already seen. I want to directly execute it. The command is sh space file name. Press enter. hit enter. Now you see, it is displaying everything. It is displaying everything. So first, what it has done, you can see it has, I am executing the file. First, it has printed a message executing simple Linux commands. Now, what is the first command I have given? Who am I? Who am I means what type of user you are. So EC2 user. What is my present working directory? It has printed that. And what is the date? It has printed the date also. It has printed the date also. And then calendar, it is displaying the 2025 year calendar. 2025 year calendar. And what about this directory? What about this directory and what about this file? It has created it. How will you verify? Just execute a ls command. Just execute a ls command. You will see Kastro directory and Kastro.txt file. But before executing, here, when I have first executed, do we have the files called Kastro.txt? No. Do we have a directory called Kastro? No. Now you see it must have created automatically. Now you see there is a directory called Kastro directory, and there is a file called Kastro.txt. Kastro.txt. So like this, we can write the shell files. Like this, we can write the shell files. Right. So let us write one more shell file. One more shell file. I think so far we are going good. So you are trying to understand what I'm exactly doing here. Let's say I want to get the system details, basic details of the system. Now let me write the shell file. Hashtag slash factorial symbol /bin/bash shebang. And then let's say I want to display echo display basic system information. I'm just giving this one. And then I want to know the current user, echo. You see, I'm writing in a different way here. Echo current user. And then here I'll give it as dollar. By default, who am I is a Linux command. So I'll execute who am I. And make sure to keep it in the quotations. And then echo here. Let's say I'll give current directory. So to see the current directory in Linux, we have a command which is called as a pwd. So if Linux has to read something, we have to give dollar symbol before that, and make sure to keep it in the quotations. So current user, current directory. Let's say I want to see today's date. Echo today's date. And date is the Linux command. So I'll keep it as a $date. Close the quotations. I want to see the calendar. Echo. I'll give it as a calendar. Echo calendar. This is something that we can do. Okay, echo calendar. And then I want to give it as a cal. So what I'll do, I'll give it as a $cal. That's it. So we have written the shell file. Now let us execute this shell file. So I'll just copy this entire thing. I'll go here and I'll create a new shell file. So currently we have welcome.sh, linux.sh. Now let us write one more file. So vi system.sh. Go to the insert mode, paste the commands. Right. Now come out of it, press escape :WQ. Second method, we have seen how to execute a shell file. Now let us see the third method, which is a bash space file name. Now press enter. You see, what are the commands I have kept? Display basic system information. First it is doing that. Let me do cat space system.sh. So first, what it is going to display? It is going to print this one. It has printed. Now next, current user. So who is the current user? EC2-user. How it is executing? We have a Linux command called who am I. And then current directory. How it is coming? /home/EC2 user by executing a pwd. I want to see the date. Today's date. You can see that. Calendar. Can you see the calendar here? When you give cal, what it will display? It will display the current month and current year. So this is how we can write the shell files. Okay, this is how we can write the shell files. And again, these are basic shell files. These are basic shell files. So we will advance into the different levels of shell files as we progress towards the end of our the shell scripting course. Shell scripting course. And as I said earlier, at the end of each video, I'll be giving you some assignments. I'll be giving you some assignments. At least 2 assignments I'll be giving you. So I'll be updating these assignments in the lecture notes. So you can have a look into the lecture notes in the GitHub repository, and the GitHub repository link is available in the description of this video. 2 assignment questions will be there. So one is task 1. So task 1 is about create a basic script. Okay, create a basic script to display system information. This is a task 1. Task 2 task 2 task 2 is to work with the interactive script. So let's say write an interactive script. Interactive means it is going to collect the information from the user, and then it is going to print the message. So that's called as a interactive script. Write an interactive script. I'll give the instructions here. Okay, what it has to interact and what commands has to get executed and how the output should be. I'll give that so that you can write the task. You can write the shell files accordingly. You can execute the shell files. So this is about lecture 1, where we have understood the Linux architecture. We have also seen how the interaction will happen between the different components that are available in the Linux. And we have also understood what is meant by scripting, what is meant by shell scripting, how to write a simple shell files, and how to execute the simple shell files. Along with that, 2 assignment tasks also been given. So you can check the GitHub repository link, which is available in the description of this video. So let us meet in the next video, where we are going to see some advanced concept in the shell scripting. Thank you all.